I'm going to use this problem as a vehicle to show you how you should tackle problems of this type. And don't think that these steps apply only to a question specifically like this example. The steps I'm going to show you suit a variety of questions, although in some questions some of the steps won't apply and you can just skip them. I'm not going to get bogged down in details in this video either, such as how to actually resolve forces. I'll leave that to other videos. In this video I'm just attempting to give you an overview of the steps that you should carry out. Step 1 is to draw a diagram that represents the situation, adding forces as necessary. And you must also show the direction of acceleration with a double-headed arrow. Depending on the question, it might not always be obvious which direction the object is accelerating. But don't worry, if you choose the wrong direction, you'll end up with a negative value for the acceleration, and you'll know that in actual fact it's accelerating in a direction opposite to your arrowhead. So in this case we've assumed that we are going to be able to push this box up the slope, but if we're wrong and we find that in actual fact it slips down the slope, we would simply get a negative value for acceleration. So this is our diagram. The question mentions that the object has a mass of 2 kilograms, so here we have a weight of 2g newtons. And since it's resting on a surface, we have a normal reaction. We don't as yet know the magnitude of this normal reaction, so we'll just label it R. The question mentions the force of 25 newtons acting horizontally, and it also mentions friction, which always acts to oppose the direction of motion. Now, for an object in motion, friction is equal to the coefficient of friction multiplied by the normal reaction R. But since we don't know the value of R, and therefore can't work out the actual value of friction, we'll simply label it F for now. Step 2 is to choose 2 perpendicular directions in which you will resolve all forces. And this direction is always dictated by the direction of acceleration. And this second arrow is always perpendicular to it. We could have equally picked it pointing down. Step 3 is to resolve all forces on your diagram into the perpendicular directions you chose as your reference directions. Now I'm just going to present the result in this video. If you don't understand how I did this, it's crucial you do. And I've explained in another video in the playlist how to resolve forces into other directions. Now, friction is already travelling in my chosen directions, and so is the normal reaction, so I don't need to worry about these, but I will need to resolve this 25 newtons. And here I've resolved that 25 newtons into these 2 perpendicular components. And I'll also need to resolve this 2g newtons. So here is step 3 completed. All my forces are resolved into the perpendicular directions that I chose. Step 4. In each direction, sum your forces and set equal to mass times acceleration. Start with either of your directions and write down the direction you're dealing with. The arrowhead is significant. Forces going in the same direction are positive, those going against are negative. And so we simply collect all the forces acting in our chosen direction, taking into account their direction compared with our arrow. And finally, setting equal to mass times acceleration. Now in this direction, the vital piece of extra information we exploit is there is no acceleration. It's zero, since in this direction, the object isn't leaving the surface of the plane. Now write down the other direction, and similarly collect your forces with a sign depending on whether they agree with your reference direction or not. Again, set this equal to mass times acceleration. However, we do know that the mass is 2 kilograms. Step 5 is simple, solve equations, as at this stage that's all there really is to it, although it may require a bit of insight on your part. Don't be blinded by the complexity of the equations or the apparent complexity, just ask yourself what are the unknowns. Well, in this equation we've got one unknown, r, and in this second equation two unknowns, f and a. And you know that we can always solve an equation with one unknown. And so if we rearrange and evaluate these terms, you'll find that r is equal to 23.6 newtons. Now we've mentioned earlier that when an object is moving, friction is equal to the coefficient of friction times the normal reaction. Well, we weren't able to calculate this before, but now because we've found the value of the normal reaction, we can. I'll just add that when I've calculated friction, I haven't rounded up to 23.6. I've used the calculator memory to give me the full resolution of the normal reaction. This allows us to get rid of one of the two unknowns in this equation. Consequently, we have an equation with one unknown, a, which we can then solve. And we're done. It's a positive value, so in fact our initial assumption was correct. The box is travelling up the inclined slope with an acceleration of 7.06 meters per second squared. So just to recap, here are our 5 steps. Draw a diagram showing the forces. Choose perpendicular directions, and as I've said, this will be dictated by the direction of acceleration. Resolve all forces as necessary into those perpendicular directions. In each direction, sum your forces and set equal to mass times acceleration. And finally, solve the equations as necessary.